Welcome all. In this lecture, we will discuss about solving a circuit using mesh analysis. So consider this circuit. So before explaining the steps of mesh analysis, we can call back the terminology loop. So a loop is related to a circuit is any closed path in a circuit. So in this circuit, this A, B, C, F, E, A is a loop. This is a closed path. And another loop is A, B, C, D, E, A, this closed path. And another one is E, D, F, E, D, C, F, E, this path, this loop, this closed path. Another one is E, D, F, E, and this D, C, F, D. So there are total 5 loops. And we are defining another terminology, mesh. So a mesh is a loop having no inner loop. Mesh is a loop, but the property is it has no other inner loop. So for example, so this A, B, C, F, E, A, this is a loop. So it has an inner loop. This one is inner loop, this one is inner loop. So inside this loop there are many loops. So it is not a mesh. So this A, B, C, F is a outer loop and it has many inner loops. So this is not a mesh. Consider A, B, C, D, A. So this A, B, C, D, A. So inside there is nothing. So it is a loop having no inner loop. So it is a mesh. So A, B, C, D, E, A is a mesh. Then consider E, D, C, F, E, D, C, F, E, this loop. So if you consider this loop, it has two inner loops. This is one loop, this is one loop. So this loop is not a mesh. The next E, D, F, E. So E, D, F, E. So it has nothing inside it. So it is a loop having no inner loop. So it is a mesh. Similarly D, C, F, D. D, C, F, D. So this loop has nothing inside. So it is having no inner loop. So it is also a mesh. So there are 3 meshes in this circuit. Next we can discuss the steps involved in solving a circuit using mesh analysis. So first step is we have to identify the meshes in given circuit. So considering this circuit, first mesh is E, D, F, E, this mesh 1. Next mesh is A, B, C, D, E, loop having no inner loop. So this is the second mesh. Then third one is this one, D, C, F, D. So this is the third mesh. So the step 1, identify the meshes. So there are 3 meshes. Next step is we have to assign the mesh currents with direction as clockwise direction. So this is the first mesh. So we have to assign the mesh current as I1 and the direction should be clockwise direction. This is mesh 2. So current is I2. Direction is clockwise. Here also mesh 3. So mesh current is I3 and the current direction is clockwise. And next step is we have to write the KVL equations for all meshes, taking loop direction as clockwise. The mesh current is clockwise and we have to find the KVL and we have to take the direction while writing the KVL as clockwise. Means we have to follow in a clockwise direction. So consider first mesh 1, this mesh. So there are R3, R2, R4, V2. While KVL equation we have to consider the voltage across R3, voltage across R2, voltage across R4 and this voltage source V2. So first R3, for a resistor we have to take it as we have to take the direction same as, so we have to follow from here R3, then R2, R4, V2. This the loop direction should be clockwise. So for R3, consider R3. R3 is only associating with this mesh, but R2 is associating with mesh 1 and mesh 2. R4 is associating with mesh 1 and mesh 3. So if you are considering R3, it is associated with only mesh 1. So it is very easy to write the voltage across this R3 as it will be equal to plus R3 into I1. Okay, since the loop direction and the mesh current direction is same, so it will be plus here. Then plus R3 in case of R3. Then we are moving to R2. So in case of R2, this it is associated with mesh 1 and mesh 2. Okay, so this for mesh current mesh 1, it will be R2 into I1. This is I1. Then there will be two currents, I1 and I2. So I1 will be positive since this is the same direction. Okay, I2 is in the opposite direction, so we are moving in this direction. Loop direction is clockwise. Okay, so this is here, but I2 is in this direction. Okay, so this direction is opposite to this direction, so I1 and I2 are in opposite direction considering R2. Okay, it is flowing like this through R2, and through R2 I2 is flowing like this. So I1 and I2 are opposite, so I1 minus I2. So we have to write as I1 minus I2. We have taken I1 first because we are writing the equation for mesh 1. Okay, and we only want to note the direction of I2. If I2 is in opposite to I1, should be minus. If it is same, it's plus. The next one R4. So R plus R4 into, there will be mesh current I1. Okay, so we have taken I1. I1 will be plus. Then there will be current I3 also. Mesh current I1 is flowing through this direction. I3 is in opposite direction, in this direction. So I3 is opposite. So I1 minus I3. Here also first we have to take a mesh 1 current because we are taking the mesh 1 here. So R4 into I1 minus I3. Then we are taking the voltage source. So while considering the sign convention of voltage, the voltage is V2. We have to write either plus or minus. So we should follow the sign convention as should be positive. The voltage should be positive if the loop direction, we are moving like this. So move direction is entering positive, and negative if the loop direction is entering negative. So here the loop direction is this and it is entering plus, so it is plus V2. So this mesh is over, so sum is equal to 0. Similarly for mesh 2, we have considered this mesh 2. So we have to consider the voltage across R2, voltage across R1, and this voltage source V1. So firstly R1, we can take R1. So first R2. So R2 means the mesh current I2 is flowing like this, and it is associated with I1 also, mesh also. First we have to take the current I2 because we are considering now mesh 2. Okay, then it is associated with the I1 also. So and here this, now we are considering this, so it is in this direction, and this I1 is opposite to that, so minus I1. Then R1. So R1 is only associated with mesh 2 only, so R1 into I2 only. Okay, then this we are voltage source V1. So for voltage source V1, we are following this direction in clockwise direction. For mesh 2, clockwise direction. So this mesh direction, loop direction is entering minus, so it is minus V1, and the sum is 0. Then for mesh 3, so for mesh 3 we have to consider this V2, R4, V1 and R5. Voltage V2 and voltage source of V1, then voltage across R4, voltage across R5. So first we can start from here. So it is this loop direction is clockwise, so it is entering in minus, so it is minus V2. Then for R4, so R4 is associated with mesh 3 and mesh 1. So for mesh 3 we have to write I3, the current of mesh 3, and this current is opposite to this loop direction, so it is opposite, minus, so I3 minus I1, R4 into I3 minus I1. And similarly next one is this voltage source, so the loop direction is entering plus, so it is plus V1, and again this R5 is only associated with the mesh 3, so it is clear R5 into I3, total is 0. So these are the KVL equations for meshes, each meshes. Then now we have these three mesh equations. So if there is number of meshes, there will be number of mesh equations also. Then next step is we have to rearrange these mesh equations to write in standard form RIV. So R into I1, some term, another R in I2, R into I3 equal to V, in that form. So first we can take mesh 1. So here with I1 there is R3 I1, R2 I1, R4 I1. So R3 plus R2 plus R4 I1. Then for I2 there is minus R2 only, so minus R2 into I2. Then if considering terms for I3, it is minus R4 only, so minus R4 I3, and equal to minus V2. V should be in this side, Ri equal to V, so V in this side. Similarly mesh 2, for I1 there is only R2, so minus, so this is equation number 1, so minus R2 I1. Then for I2 there is R2 and R1, so R2 plus R1, and there is no I3 term, so 0 I3 equal to this V1 become here plus V1, so V1. So this is a mesh 2, equation number 2. Then considering mesh 3, for I1 term is minus R4, so minus R4 I1. There is no I2 term, so 0 I2. I3 terms are R4 plus R5, so R4 plus R5 into I3, and V, so this V minus V2 become here plus V2, plus V1 become minus V1. So these are the three equations to be solved. So next we have these three equations in standard form, Ra equal to V, and we have to solve these mesh equations to obtain the unknown mesh currents I1, I2, I3. So for that we can use the Cramer's rule to solve these mesh equations. So first we can find the delta determinant. It is determinant of this term R3 plus R2 plus R4 minus R2 minus R4, coefficients of I1. Then coefficients of I2 become the next column, R2, R2 plus R1, 0. Then coefficients of I3 in the last column, minus R4, 0, and here R4 plus R5. So that is delta. Then we have to find delta 1. Delta 1 will be the same as delta, but the first column will be replaced by the voltages, the equal to coefficients. Okay, V2, V1, V2 minus V1. Okay, this will be replaced by this V2, V1, V2 minus V1. Then delta 2 will be same as delta, but the second column will be replaced by this voltages, V2 minus V2, V1, V2 minus V1. Then delta 3 become means same as delta, but the third column will be replaced by minus V2, V1, V2 minus V1, constants in the equation. Then we can find the I1 as delta. This will be a value, determinant of this be a constant value delta, and delta 1 will be another value. So delta 1 by delta will give I1, then I2 will be delta 2 by delta, I3 will be delta 3 by delta. So now we got the mesh currents. So by getting mesh current we can find the current through each resistors. For example, through R3, so suppose this is the direction of current through R3, we can say it is I1 itself, same we have to note the direction, so I1. Then for R2, if this is the direction, it is I1 and I2 is in the opposite, so I1 minus I2. And for R1, it is in this direction, so it is same as I2. And for R4, if you are taking this direction, it is I1 minus I3. Okay, and R5 it is I3. And next we can find the current delivered by voltage sources. So current delivered by this V1 is from plus, so from plus like that, it is delivering means it will be flowing from plus. Okay, so it is in this direction. This direction means it is I2 and I3 is in opposite, so I2 minus I3. And for V2, if current delivering is from plus, okay, so current delivering will be from plus, so it is in this direction, so it is I3 is in the same direction, I1 is opposite, so I3 minus I1. So by this we can wind up this session. Thank you.